So this is the second lecture on magnetic properties of materials. So this lecture will be dividing into two parts. In the first part, we'll be discussing on magnetic susceptibility and magnetic permeability, and in the second part, we'll be discussing on dia and paramagnetism. Now, let's start the part 1 of this lecture, in which we'll be trying to understand what is magnetic susceptibility and what is magnetic permeability. A key point to start with is that for most of the materials, m bar, that means magnetization vector, is proportional to h bar, that means magnetic field intensity, that is m bar is proportional to h bar, or m bar is equal to a constant of proportionality chi into h bar. Let's call this equation as equation 1. Now where chi is a proportionality constant which is called susceptibility of the material. Now the equation 1 gives m bar is equal to chi h bar, and this is an equation of a straight line with slope is equal to chi. Thus, for these materials, m bar varies linearly with h bar. For this reason, these materials are called linear materials. Now, for some linear materials, the value of chi, that is susceptibility, is negative. For them, the variation of m bar with h bar will be a straight line with negative slope. So if we draw a curve m bar versus h bar, then it will be find a straight line, and that straight line will be having a negative slope like this. And if chi is positive, then the variation will be a straight line with a positive slope, and the graph looks like this, a straight line with a positive slope. Now equation 1 again implies m bar is equal to chi h bar, which means chi is equal to m bar by h bar, and this implies for h is equal to 1, chi bar becomes is equal to m. That means susceptibility becomes numerically equal to magnetization. Now from this relation we can get a definition of susceptibility. So susceptibility chi is defined as magnetization produced by a magnetic field intensity of unit strength. This chi is constant for a particular material. This means the susceptibility chi is a material specific property. Now comes permeability. We know from our previous lecture, that means lecture 1 on the topic, the relation between h bar, b bar and m bar can be written as h bar is equal to b bar by mu naught minus m bar, or b bar is equal to mu naught into h bar plus m bar, which is equal to mu naught into, if you take out h bar is the common factor, then it becomes mu naught into h bar into 1 plus m bar by h bar. Now this m bar by h bar is equal to chi, that is susceptibility, so the relation becomes mu naught into h bar whole thing into 1 plus chi, or you can write b bar is equal to mu h bar, where the quantity mu is equal to mu naught into 1 plus chi, as it is obvious from this statement, and this is called permeability of the material. Now from this we can get two other aspects of permeability. One is called permeability of free space, and another is called relative permeability. Since mu is equal to mu naught into 1 plus chi, we can write mu by mu naught is equal to 1 plus chi, and so that mu suffix r is equal to 1 plus chi. So this mu suffix r is equal to mu by mu naught from this statement. That is, the ratio of permeability of material to the permeability of free space is called relative permeability, and that is denoted by mu r. Now we'll be proceeding to our part 2 of this lecture, where we'll be dealing with dia and paramagnetism.